Hi friends, welcome to VTeach. In last class, we discussed numerical problems regarding solar radiation in a tilted surface. Now in this class, we are going to discuss about solar photovoltaic cell. Now let us know about solar cell. A solar cell or a photovoltaic cell is an electrical device that converts the energy of light directly into the electricity by the photovoltaic effect. So let us discuss about solar cell. Solar cell is nothing but it converts the light directly into the electricity. See, this is the phenomena of solar cell, which is physically and chemically is also done by solar cell by both process, that is physical and chemical. So it is a form of photoelectric cell. So solar cell is also a form of photoelectric cell, defined as a device whose electrical characteristics such as current, voltage and resistance vary when exposed to light. So solar cell is also known as photovoltaic cell. It is one of the form of photoelectric cell, defined as the device which calculate current, voltage and resistance which vary to the light. So individual solar cells can be combined to form modules and otherwise known as solar cells. So now let us see the block diagram of solar cell. So this is the block diagram of solar cell. In this block diagram, the below part, this is known as upper part of the block is known as electrons and below part is known as holes. So holes is indicated, it is indicated with positive sign, and electrons is indicated by negative sign. So this black dots is known as flow of electrons. Electrons are flowing upward direction. So this red dots is known as holes that are flowing downwards. So this entire block is for electron flowing and holes flowing. So this is this complete block is known as solar panel. So when this is the sun. So with the sun is passing the rays, it hits the sunlight is hits the solar panel. By hitting solar panel, we convert light energy to electrical energy. So this is the definition for solar cell. So in this block, we are having two types of materials. One is n-type material, nothing but negative charged particles, and second is p-type material, nothing but positive charge carriers. So n-type materials carries negative particles and p-type material carries positive particles. There is a gap between positive and p-type and n-type is known as p-n junction. This p-n junction acts as a diode between negative type material and positive type material. This acts as a junction in between them. So let us once again see the block diagram. This is the solar panel, and when the sunlight hits the solar panel, the solar panel converts that coming sunlight energy into the electrical energy, which we use for household purpose. So below the solar panel, we are having two blocks. One is electron block and below it is holes block. Electron is the positive charge carrying particles and holes are the negative charging carrying particles. So in between, the energy which flow between the solar panel and electrons are the photons. Photons carries positive charge. So this photon block present in the p-type material. So in solar panel again consisting of two separate blocks. One carries negative type material and other carries p-type material. This n-type material is nothing but negative charged particles, in which only negative electrons flow in this. Second block is p-type material. In this, only positive charge carriers will be flown through them. So there is a bridge between p-type material and n-type material. In this p-type, these two between p-type and n-type, there is a junction called p-n junction. This junction divides the both p-type, n-type separately and p-type separately. So this is the solar cell. The main definition of solar cell is it converts light energy to electrical energy. It is also one form of energy. It is also a form of photoelectrical energy. So there are some electrical characteristics that lies in between them. They are current, voltage and resistance. Now we can go to the photovoltaic modules and arrays. So the basic block of photovoltaic module is photovoltaic cell. Photovoltaic module is nothing but photovoltaic cell. This converts solar energy into electrical energy. This photovoltaic cell converts solar energy to electricity which we use. So the power output will depend on the amount of energy incident on the surface of the cell and the operating temperature of the photovoltaic cell. So the output which we give is the energy at some operating temperature. The output will be the current or electricity to the photovoltaic cell. So the output is a single cell and can supply some loads like calculators and watches. But in order to be useful for high energy demand projects, this cell must be arranged in series and parallel. For single cell, we can only send outputs as calculator and watches as outputs. For multi cells, we have to connect all the outputs in a manner that they should be in series and parallel connection. The photovoltaic module is the array of photovoltaic cells that are pre-arranged in a single molding mold. So they are arranged in single mounting mold. This type of module is therefore determined by cells that compose the module itself. There are in this photovoltaic cell we have three cell technologies. Three dominating cell technologies are there in this PV module. The three are monocrystalline, multicrystalline, thin film. So let us see individually. First, monocrystalline. This monocrystalline is nothing but the name itself implies there is only a single crystal. In monochromatic crystal, only single crystal present in it. The name itself indicates mono means single. So the production methods are difficult and expensive. Because of this single crystal, the production method will be very difficult and also it is very expensive. One of the biggest disadvantage of the monocrystalline. So this tend to be more efficient and more expensive. With this, the monocrystalline is the very expensive and this is the one of the biggest disadvantage to PV cell. So second is multicrystalline. The production process allows multiple crystalline structures. The name itself, multi means multiple. The name itself indicates that multi means multiple crystalline structures are available in this cell. So it is easy to implement in a production life. So because of this, multi-cells is easy to produce the output very easily, and it is relatively cheap when compared to crystalline. So it is relatively very cheap, and monochromatic is expensive of lower efficiency. So we can see the monochromatic, it is only single crystal is available. So with that single cell, its operation will be very difficult and it is very expensive. Because of this operation difficultiness and expensiveness, it is disadvantage to PV cell. When coming to multicrystalline, it is having multiple structures and it is easy to operate. It is easy to product electricity, and also compared to monochromatic, it is very cheap and it is having good efficiency. So now thin film uses less silicon to develop the cell, allowing the cheaper production cost. So silicon is high in demand. So in thin film we use silicon. So silicon is in very high demand. So it tends to be less expensive and also have low efficiency. So it is less expensive and lower efficiency. So this is about thin film. Now we can move on to arrays. So photovoltaic cells are connected electrically in series or parallel circuits to produce higher voltages. So photovoltaic cells are always connected in series manner or parallel manner, such that it produces high voltages. High voltages, currents and power cells. Both voltage, current and power. So photovoltaic modules consist of PV cell circuit sealed in an environmentally protective laminate. So these are, see this block diagram. This is photovoltaic cell. This is module. This is panel, and this is array. These are kept in a properly productive laminated. So and are fundamental building blocks for PV system. This photovoltaic cell, module, panel and array, these are the building blocks for the PV cell. So photovoltaic cells includes one or more PV modules assembled as pre-wired field installed unit. So a photovoltaic array is a complete power gridding unit consisting of any number of PV modules and panels. So PV cells can consist of any number of arrays, modules and panels. There is no limitation for this. So the overall efficiency of the module will depend on cell efficiency. So the PVC efficiency depends mainly on cell efficiency only, and the placement within the module and on the laminated materials, not only on the cell efficiency but also modules that are arranged in it and also the laminated material. So the standard testing condition of this is 1000 watts per meter and an ambient temperature is 25 degrees. So standard temperature is 1000 watt per meter square and ambient temperature is 25 degrees centigrade. So the typical module efficiency ranges between 11% to 17%. The efficiency will lies between 17% to 11% to 17% for crystalline technologies. So in thin films, the efficiency lies between 6% to 12%. This is for thin films. Thin films, it lies between 6% to 12%. So about 90% of the current production used wafer-based crystalline silicon technology. So in nowadays, 90% of our we are using wafer-based silicon technology only. So the main advantages of this technology was that complete production line could be bought, installed and manufactured within a relative short time. So the predictable production startup scenario constitutes a risk placement with high expectations for return on investments. This is the major advantages and disadvantages of the photovoltaic cell, monocrystalline, multicrystalline and thin film that we are used in PV cells, and also definition of solar cell and the working principle of solar cell. Thank you.